Good morning everyone, myself T. Ram Reddy, I am from ECE. Today and the subject is satellite communication. Today topic is about a GPU aware parallel index for processing high dimensional big data. Introduction to high dimensional big data. High dimensional data refers to a data sets with a large number of attributes or features. Managing and querying such data efficiency pose significant challenges due to the course of dimensionally effective indexing methods are essential to enable fast data retrieval and analyzing the high dimensional spaces. We know that a GPU aware is a GPU aware of the parallel index for processing high dimensional big data is a specialized data and algorithm framework designed to leverage the massive parallelism and memory hierarchy graphics processing units for fast and efficient indexing, searching and retrieval in the data sets number of dimensions and records big data. Here the breakdown of such system analysis. Here what is the problem we can solve that high dimensional data like vectors plus 100 plus dimensions are computationally challenging, of course of the dimensionally, which make the traditional indexing methods inefficient. Big data at scale problems millions or billions of records which can overwhelm CPU systems. GPUs offer massive parallel capabilities but require special design to handle the access branching logic found indexing. And the concepts in the GPU is the parallel indexing and the high dimensional data handling, GPU of optimization techniques. In the challenges at high dimensional data processing, the traditional indexing structures often suffer from poor performance or dimensionally increases. High computational complexities and memory consumption and scalability data sparsity and in increased such spaces requires innovative solutions in to maintain efficiency. The role of GPUs in the big data processing is the parallel indexing, high dimensional data handling. Parallel indexing is nothing but GPU aware indexing methods need to design to allow parallel construction, building the index in parallel across GPU threads or codes. Parallel querying, distributing such workloads across the threads to speed of lookups. High dimensional data handling, common representative vectors, imagine embedded document vectors and the challenges. Traditional tree based indexers like KD trees artists degrade in the performance and the distance matrices. Example, Euclidean cosine become less meaningful. Role of GPUs in the big data processing. Graphics processing units, GPUs offer massive parallelism beneficial for large scale data processing. GPU accelerated computational intensive tasks, reducing query response time significantly. Leveraging GPU capabilities requires designing data structures optimized for parallel execution. GPU optimization techniques. Memory coalescing, optimized data layout for contiguous memory access. WAP level parallelism, match thread or workload to WAP 32 thread execution units, minimizing leverage, avoid if else branching, it causes threads to WAP execute. Design options for GPUs aware parallel indexing. Approximate nearest neighbor AN structures. Facebook AI similarity research. Highly optimized library user product quantization inverted file. And HNSW, hierarchical navigable small world graphics. HNSW on GPU allows fast search through a navigable small world graph structure. Tree based indexes. GPU variants. GPU RT adapted R3 with flattened tree layout and optimized traversal for GPU. CUML for from Rapids offer GPU accelerated KD trees, ball trees for lower dimensional grid or ash based indexes. LSH, locality sensitive hashing map high dimensional vectors to hash buckets can be for GPU. Grid quantization, divide the high dimensional space to decrease grid cells and propose architecture and the high level design. The principles of a proposed parallel indexing. The indexing used hierarchical structure, partition data and reduce such space. It employs the parallel algorithm for construction, maintenance and querying. The maximize of the GPU utilization. Memory layout is optimized for collapse access to minimize latency and improve the throughput. Key components of the data structures. They are the core components in the multi-level tree that adapts to high dimensional future spaces. Auxiliary data adapts data structure, supports fast nearest neighbor searches and the range queries. Index updates are designed to be concurrent, minimizing bottlenecks during dynamic data insertion. Parallel query processing mechanism. Queries are executed in parallel across multiple GPU threads to leverage massive concurrency. The index employs pruning strategies to quickly eliminate irrelevant data regions. Results are aggregated efficiently using GPU shared memory and reduction techniques. Query interpreter, query reschedule, evaluation plant, such some of the experiment evaluation and the results. The process of the GPU aware indexing outperformance traditional CGPU based on the indices in both speed and scalability. Experiments on real world high dimensional database query latency of the database shows the significant reduction in query latency. The index maintain high accuracy and the efficiency even in the data size and dimensionally increase. Applications and use cases. The index is suitable for high dimensional similarity such in multimedia, bioinformatics and sensor networks. It enables real-time analytic and the decision making in a big data environments. The approach of the supports scalable machine learning workflows that involves high dimensional future spaces. And the high dimensional data set vectors from high dimensional data set vectors to GPU optimizes index builder. Example PQ HNSW, and that from GPU residence index to host memory cache to GPU residence index to parallel query processor distance calcs KNN such. The benchmark to evaluate index build time. CPU versus GPU. Query throughput, queries per second, query latency, average response time, accuracy, approximate scalability, data size, dimensional. Useful tools, libraries. Phases. Phases is now full form of phases is Facebook GPU accelerated similarity search library. CUML part of Rapids offers GPU accelerated machine learning and indexing. Potential research contributes proposing a novel GPU parallelized index structure. Example GPU HNSW hybrid index. Trade-off studies accuracy versus performance versus memory. Applications in real-world domains. Example bioinformatics, NLP, computer vision. And applications and the use cases. The index is suitable for high dimensional similarity search in multimedia, bioinformatics and the sensor networks. It enables real-time analytic and the decision making in a big data environments. The approach supports scalable machine learning workflows that involves high dimensional future spaces. Conclusion and the conclusion. The conclusion and the future directions. The GPU aware parallel indexing provides an effective solutions for high dimensional big data processing. Future work includes including extending the index for dynamic data sets and the multi GPU environments. Continuing this optimizing will focus on the reducing memory footprint and improving adaptability to evolving data characteristics. Okay, thank you.